So let's suppose that we have an object that has a mass of 1500 kilograms and it's moving along our ground along the x-axis with a velocity of 75 kilometers an hour. Now our object comes to a complete stop over a distance of 3 meters and it's stopped by a spring. Now this spring has a certain stiffness to it given by a spring constant. And we want to calculate what this spring constant K is. So let's begin by assuming that there is no friction and that there are no drag forces such as air resistance. So here we have the diagram. We have an object traveling along the ground with some velocity given by this value. Now, eventually our object hits the spring and the spring creates a non-constant force, and that non-constant force acts on the object, stopping our object from a velocity of 75 kilometers an hour to a velocity of 0 kilometers an hour over a distance of 3 meters. Now, given that information, we want to find the spring constant. So let's begin by asking two very important questions that will essentially help us solve our problem. So, question number one. How much energy does our object have? So initially our object is moving with the velocity, and that means it has a certain kinetic energy. Now when the object stops, it has zero kinetic energy. So that means our change in kinetic energy is simply equal to our initial energy of the object, because the final kinetic energy of the object is zero because its velocity is zero. So that means if we look at question number two, how much work is required to stop the object? Well, the spring must act on the object. It must do work on the object to stop that object. So in fact, the spring does an amount of work that is equal to the kinetic energy of the object. So we can use our equation, which we'll look at in a second, to solve for our spring constant K. But first, let's look at our velocity. So our velocity is given in kilometers per hour, and of course we're dealing with meters per second. So that means we must first convert our kilometers per hour to meters per second. So we essentially take 75 and divide it by 3.6, or we could simply multiply our things out. So there are 1,000 meters in kilometers, so kilometers cancel and meters are left on top. Then we multiply by 1 hour divided by 60 minutes and 1 minute in 60 seconds. So we have meters cancel, hours cancel, and we're left with about 21 meters per second is our initial velocity of the object. So using this information, let's calculate question number one. Let's answer question number one. How much kinetic energy is in our object when it's traveling with a velocity of 21 meters per second? So that's simple enough. We have our formula, 1/2 times m times v squared. So we know the mass is 1500 kilograms. We know our initial velocity is 21 meters per second. So we take the product of the square of the velocity and our mass of the object and divide that by 2, and we get approximately 300 or 330,750 joules of work. So that's how much kinetic energy is found in our moving object. And that is exactly how much kinetic or how much energy, how much work must be done on the object to stop our object from moving. So the energy into compressing the spring basically means that this is how much energy that must go into the spring to compress our spring. And that's equal to 1/2 of the spring constant multiplied by the square of our displacement. So we know that our change in position is 3 meters. So that's 3 meters squared, and we know the energy is equal to our kinetic energy. So we plug our knowns into our equation, and we see that the energy, our kinetic energy, or the work that must be done to stop our object is equal to 1/2 times our unknown multiplied by 3 squared, so 9. So we multiply both sides by 2, we divide both sides by 9, and we get that our spring constant is equal to 73,500 500 newtons per meter. So this is our spring constant. It's the stiffness in our spring.